What are the three key ideas, sir? Transmission of charge, partial charge separation across sigma bonds of carbon chain. It is minus delta, it is delta plus. It is delta delta plus. It is delta 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 plus. It is delta 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 plus. The effect is really 0 beyond fourth carbon. So, transmission of charge, partial charge separation across sigma bonds of carbon chain due to bonded group is called minus inductive effect or
Sir, which topic you are doing?
Excuse me? What did you say?
No. Sir, we were discussing NCERT textbook now, sir.
Yes, sir. I'll take you there. But it is not clearly there, so I am showing my own writing. We are going there. In the NCERT book, they wrote only 2 carbons. I have written 4 carbons. And they said it is, they did not say anything how long it will be there. I am saying it will be there maximum up to 4th carbon. The effect will disappear after 4th carbon. The electrons are going away from carbon chain. It is called minus psi effect. Sometimes when carbon chain is linked to atom like copper, the electrons are flowing towards the carbon chain because it is less electronegative. This flow of electrons into carbon
Sir,
chain
only 33 members joined, sir.
What can I do? What can I do? Tell me. This got disconnected. It is not under my control. Now it got reconnected. Now I am trying to do whatever I should. I am saying that whenever there is a carbon chain, if electrons are taken away from carbon chain, it is called minus psi effect. If electrons are entering into carbon chain, it is called plus psi effect. Both these effects involve transmission of partial charge across carbon chain through sigma bonds. This is a permanent effect. These effects will increase the polarity of molecules and increase their reactivity. Are you very clear? Hello?
Yes,
Hello?
sir. Yes, sir.
Now we are looking
Minus
at
plus I effect. Understood, sir.
Sir, these are groups like halogens, NO2, CN, COO, COOR, OAR, OC6H5. All these are electron withdrawing groups. They are minus psi groups. The methyl, the ethyl, the propyl, the copper, the zinc, the aluminum, all they are plus psi groups.
Electrons flow away, sir. Electrons flow away from this, sir.
When the carbon chain is linked to Cl, Br, I, F, NO2, C6H5, COO, etc., electrons go away from carbon chain. Carbon gets plus delta, the X gets minus delta. It is called minus psi effect. When carbon chain is bound to copper, silver, zinc, aluminum, or methyl group, ethyl group, propyl group, etc., the electrons will flow into carbon chain. When they increase the electron density in carbon chain, they are called plus I groups. Look at these examples. Which bond is more polar? CH3H, CH3Br. Which is more polar? Which is more polar? CH3H or CH3Br?
CH3Br.
Yes, sir. Which is more polar?
CH3Br.
CH3Br, because Br is more electronegative. Which is more polar? CH3NaH2, CH3OH. Oxygen is more
Sir, here
electronegative than
polar
nitrogen.
means
Positive pole, negative pole. Polar means which is getting more charge separation. More electronegative groups take more charge through sigma electrons. Now, which gets more charge separation? N of CH3NaH2 or O of CH3OH? Which gets more polarity?
NH2.
No, I don't know. If you don't know fundamental concept, I can't help. Which has more electronegativity, nitrogen or oxygen? More electronegative atom can more readily take away electrons from carbon chain. You should compare the electronegativity with respect to hydrogen. If hydrogen is 2.1, nitrogen electronegativity is 3. Oxygen electronegativity is 3.5. Fluorine electronegativity is 4. So which bond will be more polar? CN bond, CO bond, CF bond. Which is more polar?
CF, sir.
CF is more polar. Okay. They are called minus I effects. Now, which bond is more polar? CH3OH or CH3SH? Which is more polar?
OH.
Perfect. Now, in which is CC bond? CH3, CH2, CH2Br. The inductive effect is expected to be least. Is it there on carbon number 1, 2, or 3? Where it is least? Where it is least?
EH.
Br is linked to carbon number 1. Carbon number 1 is linked to carbon number 2. Carbon number 2 is linked to carbon number 3. In which carbon charge separated is least? 1, 2, or 3?
Least, sir.
The charge separated will die away as you are going away. Third carbon has lowest charge. Are we very clear about inductive effect? Hello? Are we very clear? Yes. What is inductive effect? Partial charge separation. Through what? Carbon chain. When it happens, when it is linked to either more electronegative atom than hydrogen or very less electronegative than hydrogen. If more electronegative atom is bonded, what happens? Carbon chain gets plus charge. If it is bonded to less electronegative atom, carbon chain gets minus charge. What is the first variety of groups known as minus I groups? Which is the most powerful minus I group? NO2. What is the other variety of groups? Plus I groups. Which are plus I groups? Copper, zinc, aluminum, methyl, ethyl, propyl, etc. Now, look at benzene. There is a compound called benzene whose formula is C6H6. Can you look at structure benzene?
Yes, sir.
Can you look at benzene? In benzene C6H6, there are double bonds between carbons and also there are single bonds. Can you see that?
Yes, sir.
Yes. It means there are 3 C double bond Cs, 3 C single bond Cs. Always double bond length is supposed to be C double bond length is 133 picometers. C single bond C bond length is 154 picometers. In benzene, 3 bonds should be of 133 picometers length. 3 bonds must be 154 picometers length. Yes or no? Yes? Yes.
Yes, sir.
But unfortunately, in benzene, neither of the bond is found to be 154 or nor 133. All bonds are found to be equal with a length of 139 picometers. Now,
Why,
in
sir?
order to explain this fact, we understand that in benzene there is neither a single bond nor a double bond. It is in between. In fact, benzene structure is represented as a hybrid of these. In this structure, you can see in first structure there is a double bond between 1 and 2. Whereas in second structure there is a single bond between 1 and 2 carbons. Position of double bond is shifting. Can you see that?
Yes, sir.
So really the structure of benzene is supposed to be a hybrid of these two possible structures. These structures are called resonance canonical structures. The molecule is said to be under resonance. Notice double bonds are not confined to 1 and 2 carbons. They are shifting their position. The shifting of position of double bonds is called resonance or delocalization. What is it called? Delocalization. The delocalization is possible only when the system is in conjugation. In a conjugated system, there will be double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, like that. In conjugated system, relative positions of the pi bonds will shift and the molecule get a kind of hybrid structure of all this. Neither one or two exists. Real structure is a hybrid of all this. If you cannot explain all properties of a molecule with any single structure, you write several possible structures, and the real structure is thought to be a hybrid of all this, and this phenomena is called resonance. The resonance always increases the stability of molecule. In resonance, pi electrons are always delocalized. They are not confined to one locality. They keep on moving. To have the delocalization or movement, the system should be conjugate. Conjugate means double bond, single bond, double bond, single bond, double bond, single bond, like that. In conjugation also means positive charge, single bond, double bond, single bond, double bond, single bond, double bond, or negative charge, single bond, double bond, single bond, double bond, single bond, double bond, like that. Whenever there is a conjugated system, there can be resonance, and resonance always increase the stability, and resonance stabilization it is called. The resonance structures or canonical structures are hypothetical. Individually, they do not represent anything, but real structure is a hybrid of all this. Look at nitromethane. In nitromethane, first oxygen has double bond, second oxygen has negative charge. But negative charge can become double bond can become negative charge. The real structure of nitromethane is neither one nor two. It is in between. Due to the possibility of resonance, any molecule gets extra stability. The extra stability it gets is called resonance stabilization energy. Notice, you can write many resonance structures, but in all resonance structures, total number of electrons must be constant. The relative position of atoms must be constant. The formula must be constant. Now we understood what is resonance. Using the concept of resonance, we can explain many questions in organic chemistry. How to use resonance concept to explain relative questions tomorrow we see. Notice, due to resonance, if you carefully look at, there is a compound called aniline. Benzene is linked to NH2. Here you can see the lone pair, single bond, double bond, single bond, double bond, single bond, double bond, single bond. The lone pair of nitrogen is in conjugation. Okay. Okay. Sir, if you carefully observe aniline, an organic molecule that has NH2 on benzene, you would see that there is a lone pair on nitrogen which is connected to single bond, which is connected to double bond, which is connected to single bond, like that. This conjugated system will allow the flow of electrons from nitrogen to benzene. Because nitrogen has given away the electron, it got plus charge. And because the carbon has taken the pi electron, it got minus charge.
Sir, Abdullah Haqqani, sir.
Number?
11,
Number,
sir.
please?
11. JL 41, 11.
Okay. Never mind. Don't get irritated. It happens. In life, so many things happen. We should never get irritated. Okay? Don't get irritated. Come on. He's not there.
Sir, he left, sir.
Very good. Congratulations. Now I will not allow him because I will close this. Sometime back, what I have done is I kept the waiting room option. I close it now. Okay, sir. Now what we were talking, sir? What we are talking, sir? In aniline, you can see NH2 is linked to benzene. You would see that there is a lone pair on nitrogen, linked to single bond, linked to double bond, linked to single bond, linked to double bond, like conjugation. Due to the conjugation, electrons can flow. So that you got a double bond and nitrogen got plus charge, oxygen got minus charge. Again, the minus charge can come in between carbons, pi electron go on to another carbon. This possibility of resonance will facilitate the flow of electrons from nitrogen to benzene. It results in double bond nature between C and N bond, number one. Non-availability of lone pair of electrons on nitrogen due to resonance. Anybody who can donate electron pair is called base. Ammonia is a base. But aniline is not a good base. Why aniline is not a good base? Can anybody tell me? Why aniline is a poor base? Sir, what is a base? Lewis base is one who can donate electron pair to needy. This compound, benzene NH2, is called aniline. Aniline is a poor base. Why it is a poor base than ammonia?
So because they are very poor at sharing electrons.
Now, why it is a poor base? Anybody who has a lone pair of electrons can donate. Anybody who donates lone pair of electrons is a base. Ammonia is a base. When compared with ammonia, aniline NH2C6H5 is a poor base. Why it is a poor base than ammonia?
Because aniline is more stable. I think like that, sir.
Please observe. Who is a base? Base is one who can donate a lone pair of electrons. In ammonia, nitrogen has a lone pair. It can donate happily to anybody. It is a good base. In aniline also, nitrogen has a lone pair. But unfortunately, aniline is a weaker base than ammonia. Why like?
Because it can give some very less amount of electrons when compared to ammonia. Disconnected.
Jellyfish.
सर डिस्कनेक्ट हो गया क्या? Did sir got disconnected or we have to leave the meeting?
कोई ऐड कर दो मीटिंग एंड कर दो
हाँ एंड कर दो
एंड कर दो जिले भाई